Let's have a look at exercise 4 here. So we have an employee that lives for 2 periods. Now, those periods are when he is young and when he is old. Every period he chooses between working hard and not doing anything. So work versus shirking, so to speak. Working hard has a cost. Not working has no cost. There's a probability P that the worker is going to be caught, and the probability 1 minus P that the worker is not caught by the employer that he's shirking. If the employer doesn't catch him shirking, then he still gets his salary, he still gets his wage, and that wage differs between being old and being young. Now, what matters here in question 14? If the salary is higher than the following, then the old employee chooses to work hard. So what we're interested in, under which scenario does the utility of an old employee of working is going to be greater than the utility of the old employee of shirking. So we want to know, when does the old worker decide to work? Okay, what's the utility when he is working? That's going to be a regular utility. The utility, it's also given somewhere in the question. I don't read the entire question to save time, but it's given over here that the utility is equal to the income minus the cost of effort. So we have here the difference between the income, the salary, minus the cost of effort, and notice that I put this index of old because the wage differs between young and old people. It's given over here. The wage differs between old and young employees. Now, this utility of working has to be greater than the utility of shirking. And when the worker shirks, then he is not putting any effort. Now, there is a probability that he will be caught. And with that probability, he gets zero money, and no cost. So overall, he gets nothing. He's just fired in this case. So that's the probability of being caught, right? Caught when shirking. Caught while shirking. That's one scenario. But then there's the remaining probability. There's the remaining probability 1 minus P, that the worker is not caught shirking. So he'll get his salary, but he has no cost of effort. So the cost of effort would be just 0. So that is the case where he is not caught while shirking. So we have here not caught while shirking. Now, let's work out the math here to see the relationship between the wage and the cost. So we will have the wage minus the cost, which is greater than, here we have a 0, right? And here we will have just 1 minus P multiplied with WO, W of the old worker. Okay, let's open the brackets to see what we get. Wage of the old worker minus the cost of the old worker is greater than 1 times the W, so WO, minus P times WO, minus P times WO. Now, to see the relationship between the wage and the cost, right, that's what we're looking for, let's take the wages on one side, the wage terms on the left side, so this one and the other one goes over there, and then we transfer the cost to the right side. So what do we have? We'll have the wage of the old worker minus the wage of the old worker plus probability times the wage of the old worker is greater than the cost of the old worker. Now let's solve this math over here. Wage minus wage goes away. We're left with probability times the wage of an old worker greater than the cost of the old worker, which means that if the wage of the old worker is greater than the cost of the old worker divided by P, he chooses to work hard. And if we have a look at the question over here, that relationship is different. So the answer here is false, and we are done.